That's how people talk. Hi, Diana. Consider the following. No, they don't talk to me like that. So consider the following. It's a math one. I didn't write down the problem. What they want you to do is answer a bunch of questions about that sequence. So the steps are the same. You would make a sample of data. Like in the weight thing, the data was sampled for me by the body trace. Here it's not. I have to plug it into this fake formula. And where the red is, your numbers will be different. So you can see me plugging and chugging. I'm just plugging it in. When n equals 1, I plug in 1 into the formula for an, and I get 1/7. When I plug 2 in the formula, I get 0.14. Can you quickly crank out 3, what you would get for 3? Just so I know that you know how to do it. The biggest problem when you do this is parentheses, putting your parentheses in the right place when you're entering it. What'd you get? 1/19? 0.18? Okay, it looks like it's coming through. And I can't remember how they ask you because I erased that part of the problem. But they might ask you to 2 decimal places, or they might ask you the exact answer. I know that on the TIs, you can tell it to switch the decimal into a fraction. So just make sure that you're not rounding if you're doing that. So 0.18, correct? Does it say? I don't remember if it says to, but everybody gets the point. If you got 0.18, everybody knows what to do. And they want you to plot the points to see the graph. I just can't stand doing things by hand with my little scrappy, scrawly thing. I just wanted to see it. And they also wanted to see what it converges to. And I just did it on a computer up to n equals 10, and I graphed it. And I can see it. It looks like it's converging to 5. I think something's wrong with my graph. Maybe it took some different graph. It's converging to 0.2. I think I switched out one of my graphs. Oh, there it is, 0.2. Wrong graph, right? So it looks like it converges to 0.2. Or we would say the limit as n goes to infinity of an equals 0.2. If you want just the answer, just stick an n equals 1,000 in there. And your calculator will tell you 0.2. How do you find it analytically? That's without algebra. That's using your eyeballs in your head. That's it, right? How do you do like a machine and find the answer? Well, here's what you do. You take the formula. First step is to divide every term by the highest power. This is a trick. So don't ask me why does it work. It's a trick that people have done for hundreds of years, and I've seen the trick. So I'm not a genius. I've seen it. And I teach it over and over and over again. So there goes the genius theory. So I take n squared. That's the highest power. And I divide every term through by n squared. I'm not changing the fraction at all because I'm really multiplying by 1 if I divide the same thing with every term. So highest power is n squared. I divide everything through by n squared. Those cancel, and I'm left with 1 over 2 to the n plus 5. Now 2 over n, as n gets large, gets small. 2 over 1,000, pretty small. 2 over 10,000, pretty small. What's the limit of 2 over n as n goes to infinity?
Close to 0.
Should be close to 0, right? Every time I plug in an n that's really big, I'm going to get something closer and closer to 0. So that piece goes to 0. I'm already jumping the gun here. Let n get large. 2 over n goes to 0. See this by just plugging it in. See it for yourself if you don't believe me. I'm named for St. Thomas. I don't believe anybody. So I have to see to believe. So you can plug it in if you want. I plugged in 1,000 and you see 0.002. You get something really small. So the limit is 1 over 0 plus 5, which is 1/5, and voila, that's 0.2. So what my eyes told me with the graphs were exactly the same as what I get analytically. Okay, I'm going to stop there.